Okay, so where is my handphone? Join now. All right. Okay, class 2 Alpha, can see my screen sharing?
Can.
Okay, very good. Thank you very much. All right. So I just continue with our previous lesson, yeah. Okay, still in topic 8.2, the effects of force. So let me see about that later. Um, right. Okay. So we are still in 8.2. 8.2 is the effects of force. Okay. If you look at the picture here, um, in lever, we already finished part of lever, meaning of the lever, and then classification of lever, moment of force, and pressure, right? So if I can write here, the next one is pressure. Okay, pressure. Pressure we already finished. Okay, we already finished the what we call the introduction of pressure, right? The introduction of pressure. So I think, is it a part of level or no? Wait, I check first. Because in 8.3, sorry, 8.2 has a lot of topic. Moment of force and pressure. Okay, let me try to write it once again. Because we want to, you must understand, we need to what we call um, know where we are right now. Okay. Okay. Right. So in 8.2, where is 8.2? Okay. Still in chapter 8 class. Still in chapter 8. Let me write it for you first. Still in chapter 8, 8, 8.2, that is effect of force. Okay. So number one, A, in effect of force, you learn about the um, number one, of course, the effects of force. You still remember how many effects of force? I think there are 6 effects. Effects of force. Number one is, for example, change shape, right? And then change direction, okay? And then change speed, and then change what else? Change the size and shape, right? Number one. The A in 8.2, the first topic is the effects of force. And then number two, who can tell me? We learn about the buoyant force. Still remember buoyant force, class? Yeah. And then how to measure the buoyant force. Yeah. How to measure it? How to measure it? By using the formula. You still remember the formula of buoyant force? Yeah. Buoyant force equal to actual weight minus apparent weight. Do you remember about this? Right? And then in C, you learn about level. Okay, you learn about classes of level. Still remember? Huh? The first class, second class, third class, and then the position of fulcrum, load, and effort. FLE. Okay, still remember that? And then the type, the example of what we call the example of tools. Okay, that use the what we call this class of level. And then of course also you already learn about the next is the moment of force. We also already finished about this, the moment of force. And number 5, E, we learn about pressure. Okay, moment of force, you also need to know the what we call the formula, or the how to calculate or how to find out the moment of force by using the formula. Moment of force is equal, who still remember what is the what we call the formula? The distance, right? Where is the formula? Force times the distance. Yeah, force from the distance times the distance from F to from the fulcrum, yeah, from the fulcrum, yeah, from the fulcrum to force. Okay, and then pressure. All right. So what is the what we call the formula for pressure? Well, Dylan, the pressure formula is force in Newton divided by surface area in meter square. Okay. Wow, so many, right? 8.2, we have so many topics. Okay. So we are still in pressure. So in pressure, you need to learn the introduction of the pressure, how to find the value of the pressure. Next one, gas pressure. All right, gas pressure. And a little bit about liquid pressure. A little bit about liquid pressure. Okay, a little bit about the liquid pressure. Okay, in gas pressure, including atmospheric pressure, meaning that the pressure in our atmosphere, because our atmosphere is consists of mainly of air, right? Oxygen and then carbon dioxide and other particles in our atmosphere. So there is a gas pressure in our atmosphere. So we're going to learn about a bit about the gas pressure. And then the liquid pressure, as the title is all about, it is about the water, the pressure of water. And then finish chapter 8, right? Can you understand this class? Can you keep track on what we are learning? Because I know in Form 2, there are so many chapters. All right. Never mind. We try to do it slowly, one by one. So this is on chapter subtopic chapter 8.2. Yeah? The effects of force. This is the effects of force. The topic on effects of force. Okay, class. Okay, next one. So I will continue with pressure. Okay, so we already learn about this. All right. And then for the experiment later on I will explain you about the experiment. Next, the application of pressure in daily life. right? So I think you can read it for yourself. What are the application of pressure? For example, number one, metals blade of skating boot thin. Okay, why are the metal blade of the skating boot tins? Because of they want to ride the metal skate ice skating smooth. And then why the blade of an axe thin? Because they want to make the axe very sharp in order to cut the tree. Right. Then next one. Why do the tractor have a big and wide wheel? The tractor here has a big and wide wheels because they want as much as what we call a little pressure on the ground so that the tractor won't sink in the what we call soft soil or soft ground. And then what the purpose of the stud on the sole of the football boots? Okay, this is a few example of the application of pressure in daily life. Okay, meaning that if you still remember, the larger the what we call the surface area, what happened to the pressure? Who still remember this one? Meaning the larger the surface area given the same weight, how about the pressure? The pressure is more, the pressure is more or the pressure is less? According to here, if you still remember the diagram here. The larger the surface area, so the pressure is lower, right? The pressure is lower, all right? If you compare it with the what we call object which has a lower surface area, the pressure is more. The pressure is more when you have smaller surface area, and then if you have the object has the larger surface area, so you can say the pressure is less. Depending on the what? Depend on the application lah. Depend on the application. For example, X need a thin blade, and then for the tractor over here must have a what we call large and big wheels, because they do not want the tractor to sink on the ground over here. Can you understand the pressure? Is it okay, class?
Okay.
Can.
Okay, all right. So next one, I will go very short today. So we continue with our topic for today is the gas pressure. Remember, gas also has a pressure, right? Okay, so if you look at the picture over here, what happened to the balloon? Example, very simple example over here. What happened to the balloon when we blow air inside it? Okay, the balloon will expand. Okay, the balloon will expand. Why the balloon expand? Because of the air pressure inside the balloon. That's why it will expand. Okay, so when air is forced out, the atmospheric pressure what we call exert the pressure in outside of the balloon, and the balloon deflates. Okay, the balloon deflate expansion, and the deflate expansion and what we call contraction of the balloon is based on the air pressure, whether the air pressure outside or inside is higher or lower. For example here, when the girls here blow the air inside the balloon, which air pressure is higher, class, inside the balloon or outside the balloon?
Inside.
Inside the balloon, yes, very good. Inside the balloon, inside the balloon, the air pressure is higher than outside the balloon. Outside of balloon, we call it atmospheric pressure. Atmospheric pressure. Okay. Then when we try to deflate the balloon, meaning that there is an opening at the balloon, the air pressure will force out, then the atmospheric pressure will take place, and then the atmospheric pressure, because they want to equalize the pressure outside and inside, so the balloon will deflate. Same things with our, if you still remember, our breathing. When we breathe in and breathe out, there is what we call a difference in air pressure. Okay, when we breathe in, which air pressure is higher, outside or inside? Breathe in and breathe out.
Breathe in.
When we breathe in, right? When we breathe in, the air pressure inside our lung is more than outside. Okay, you still remember? I think in form we already learned about this, right? Oh, breathing. I think you will learn this on form 3. Yes, form 3. Next year, form 3, you'll be learning about the system, the what we call the respiration system, when we breathe in and then we breathe out. Because there is a difference between the air outside and then the air inside that enable us to breathe in and breathe out using air pressure, right? So, never mind. Next one. Okay, you still remember the kinetic theory of gas? This is in form 1, yeah, because all matter are made up from particles. And then which particle has the highest movement? This is the particle of what? Liquid, gas, or liquid, gas, or solid?
Gas.
This is the kinetic theory, the particle of gas here. Make sure you understand this. Right. It said that the kinetic theory of gas state the air molecule always move freely and collide with the wall of the container. The frequency of collision between the air molecule and the wall of the container will produce a force that push against the wall. I will show you the okay. This is example. This is the example of air particles. Okay, this is example of air particles. If you still remember, air particle move what we call it is moving always move about freely. Move about freely. This is the air particles, move about freely and then collide, collide with wall of container. Okay, can you see the particles moving? The particles moving randomly and what we call it freely, and then it will collide with the wall of the container. For example, this is the wall of the container, the square here. This is the wall of container. Because of this action, because of the particle always hitting the wall of the container, that's why it will produce a force because it's always collide with the wall of the container, so it will produce a force. Okay, it will produce a force that push against the wall, that push against the wall of the container, that push against the wall of the container. Okay, because of the nature of the particle, the nature of the particle that is move freely and collide with the wall of the container, meaning that if the particle is more, so the pressure is higher based on the what we call, you see here the random particle. Can you see the random particle moving around inside the container? This is the square container, so the pressure exerted because of the action of this what we call the particle colliding with the wall will produce air pressure. Okay, class? Never mind. Later you see the video again. Right. Okay, this some experiment. Never mind. I will skip the experiment. Okay. So this is to what we call a device to measure the air pressure. All right. So we have here a Bourdon gauge. Bourdon gauge is just to what we call to measure the air pressure. And then we have syringe, air, and piston. Okay. What happened when I push the syringe over here? What happened when I apply the force? Okay. Wait. I apply the force over here. I push the piston over here inward. Okay. I push by using my own energy, my own force. What happened to the reading at the Bourdon gauge? The Bourdon gauge will give up a reading. Okay, why? Why I push the syringe? Because I want to compress the air. Huh? When we compress the air, the what we call the pressure inside will be higher or lower. The air pressure inside. When I push the syringe, what happened when I push? When I push the piston,
Higher.
okay, very good. The air pressure inside become higher because air is compressed. When air is being compressed, air pressure will increase, and then we can see at the Bourdon gauge here, the reading will, they will give a reading, not from zero. Okay, the same principle, when you have the what we call bicycle pump. Bicycle pump. You have bicycle pump at home with gauge. This one, which pressure gauge? This one. If you got this, I got one this at home. Not just ordinary bicycle pump lah, but this bicycle pump, for example, over here with a pressure gauge. You got the pressure gauge over here, meaning that inside the tire also got the specific pressure. You cannot pump the air too much. What happens if you pump air too much inside the tire? If you
will explosive.
will explode. It will explode. All right. When too less, you cannot put too what we call less air inside the tire, or the vehicle or your bicycle will become very slow, right? Very heavy to cycle. That's why we need what we call enough air inside the tire. Too much, maybe it will explode, and too low, you will be it's not good for the tire. Okay, this is example of Bourdon gauge here. Okay, what else? This one also got the bicycle pump with the gauge, this one also. Okay, this is the Bourdon gauge lah. Okay, next. All right. So when you apply pressure, the volume, it will compress. All right. When the volume is what we call over here, when you push the syringe, okay, the volume will, what happened to the volume? If you push the piston over here, the volume will go up. The volume they increase, and then the air pressure also increase. Okay, if I can draw the air pressure over here, for example, this one, this is the same, what we call, I just draw another one here lah. Never mind. Okay, for example, right here. So this is A, and then this is B, right? This is identical what we call container. This also identical container, all right? And then this is the piston. This is the piston, and then this is also the piston. Identical container. So this is the same piston. Okay, this is also the same piston, and then this is also identical container. Same or identical container. What is the difference? Can you see the difference? This is got 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 lah. This also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Inside we have what? The dot is the what, class? The dot inside the container is the air particle. Okay, air particle. Okay. Container in A, we do not push it. We let it, what we call, we do not push the piston in A. All right. So, what are the pressure inside and outside? The pressure is same or different? The pressure inside and the pressure outside, same or different in A?
Different.
Different. Okay. Again, I do not push the piston. Yeah, I do not push. In B, I push the piston down. In A, I not push the piston down. I will let it like that. Okay. Okay. You must understand. The volume inside is what we call the pressure inside. On diagram A, the pressure inside and the pressure outside is same. Okay. The pressure inside here and the pressure outside is same. Why? Equal. The what we call the pressure is equal because I didn't push down. I do not push down. I didn't push down the piston. Okay, I didn't push down the piston. Yeah, so the pressure is same, meaning that the volume of air particle inside the container and outside. Yeah, the air particle inside the container and then the air particle outside the container is same. So when I leave it like that, right, the pressure inside here, the pressure inside, and the pressure outside is same. Okay, same. Remember, yeah, same pressure. So what happened if I push the piston down? If I push the piston down, never mind, by using our hand, by using the what we call hydraulic or whatever, I push the pressure down. What happened to the volume inside? What happened to the volume? The volume is increased. Okay, you must remember the volume of the volume of air inside the container will increase, and then if the volume increase, what happened to the air pressure?
Increase.
The air pressure also increase. The air pressure also increase. Can you see the amount of what we call the position or the distance of air particle inside? It's become smaller. Right? And then the particle inside, B will move more. That's why the volume increase, air pressure also increase. Okay. In B, class, in B, which has the highest pressure? In X or Y? X or Y? Which
Y.
has the higher pressure? X or Y?
Y.
Okay. X, the pressure in Y has the higher pressure. Higher pressure. X, low pressure. Low pressure. Okay. What happened if I stop pushing the piston? What happened if I stop pushing the piston? What happened to the piston? What do you think? If
Will
I yes,
slowly
okay.
flow out.
Yes, very good. If you stop pushing the piston will slowly go up because they want to equalize the pressure inside and outside. Want to equal the pressure inside the container and outside the container. Okay, so it will be like A. It will be like A. That is the number one. All right. Number two, last. I'm sorry, last. Number two. Okay. What happened to the air pressure when we heat it up? What happened to the pressure when we heat up? Okay. According to the picture over here, when I heat the air inside the beaker, the pressure also increase. You just remember that. Okay. When you heat the air, the air inside the container, it will. What happened to the particle when we try to heat it up? What happened to the particle? Before we heat it up, the particle is moving or not moving? Before.
Moving.
Okay, still moving, right? Still moving fast and freely. But after I heat the air particle inside, what happened to the air particle when I heat it up? It will move more faster or it will move the same?
More faster.
Yes. Okay, you must remember, yeah. If I heat it up, before I heat it up, okay, again, before I heat the air inside the container, it move, yeah. It will move. Okay, it will move. Okay, but when I heat it up, when I heat the air more, it will move much faster. Okay, and much rigorous. And then what happened if the particle inside move much faster? It will collide with the wall of the container. And then what happened if it collide with the wall of the container more? What happened to the air pressure? What happened to the air pressure?
Higher.
The air pressure will become higher. Okay, I hope you understand this. All right. Again, you can read again about the two factor affecting the air pressure. One is volume, and then the second one is temperature. Okay, you can read and on your textbook page 191 and 92. This is the what we call I just already give you the example for this. Page 191, and then this is the temperature. This is about the temperature. On picture on the left is the air particle before we heat it up. It's still moving, but when I heat it up, it will move more faster. The faster the movement of air particle if I heat it up. That's why when air become hot, the air pressure will increase. Okay? Any problem?
No.
No problem, yeah? Okay. If you have any question, of course, you can ask me later on our Telegram group. What now is 1:37 in the afternoon. So I will continue the next topic for atmospheric pressure in Wednesday. Is it okay, class?
Okay.
Okay, very good. Where is it? Okay. Okay, tomorrow is OO. Who you? Okay, very good. Okay, tomorrow public holiday, so I will be seeing all of you again on Wednesday at, I think I want to start at 10:30. 10:30. Okay, 10:30 in the morning. Because we have so many things, so many topic yet to cover. So I will start at 10:30 on Wednesday. Okay. Okay, tomorrow is public holiday, so happy Merdeka Day. Do not forget to take care of yourself, stay safe, and then see you all again on Wednesday class. All right? Okay, you can leave the class now. Thank you very much. Bye-bye.
Thank you, teacher.
Thank you. Bye.
Bye-bye.
Bye-bye.
Thank you, teacher.
Thank you.